Here's what most people don't know. The moon landing's most profound legacy isn't just about reaching another celestial body, but about the creation of modern software engineering. The Apollo Guidance Computer, or AGC, was astonishingly primitive by today's standards, processing instructions at about 0.043 megahertz, less powerful than a greeting card. Yet this machine, guided by a team led by Margaret Hamilton, pioneered concepts like asynchronous computing and priority scheduling from scratch, essentially inventing the discipline of software engineering itself. Her team's innovations, developed under immense pressure, defined the processes and even the terminology that underpin every digital device we use today, long before Silicon Valley became a household name. The relentless demand for a lightweight, robust computer for Apollo missions single-handedly catalyzed the mass production of integrated circuits, the microchips that power our entire digital world. In the early 1960s, these chips were prohibitively expensive, costing about $1,000 each in 1962. However, NASA's guaranteed bulk orders to companies like Fairchild Semiconductor and Texas Instruments forced a massive scale-up in manufacturing, dropping the price dramatically to about $50 by 1965. This government-funded technological push made integrated circuits affordable for commercial applications years ahead of schedule, directly paving the way for the personal computer revolution and the smartphone era. Beyond the iconic images, the Apollo program laid the foundational groundwork for modern satellite navigation systems, including GPS. The precision required for celestial navigation, orbital mechanics, and accurate re-entry during Apollo missions pushed the boundaries of timing and positioning technologies. While the NAVSTAR GPS project began later for military purposes, the underlying principles of maintaining precise, synchronized clocks across vast distances and calculating positions based on satellite signals were heavily refined and validated by Apollo's stringent demands. Most people don't realize that the ubiquitous navigation in our cars and phones today owes a significant intellectual debt to the moon race. Did you know that many advanced medical imaging technologies, like CT scans and MRI machines, have roots in space exploration? The Charge-Coupled Device, or CCD, a sensor crucial for digital cameras used to capture images of the moon, was further developed to meet NASA's unique needs. This technology later evolved into critical components for high-resolution medical scanners. Furthermore, sophisticated signal processing techniques developed to filter out cosmic noise from biomedical data collected from astronauts became fundamental to diagnostic equipment, allowing doctors to see inside the human body with unprecedented clarity, directly impacting millions of lives on Earth. The everyday convenience of cordless power tools can be directly traced back to the Apollo program. To collect lunar samples, astronauts needed drills that could operate in a vacuum, extreme temperatures, and without a power tether. Black & Decker rose to the challenge, developing the first-ever cordless, self-contained power drill specifically for NASA's lunar expeditions. This innovation, driven by the unique and harsh demands of outer space, completely revolutionized tool design. It soon trickled down to consumer markets, giving us the cordless drills, vacuum cleaners, and even dustbusters that are indispensable in homes and workplaces worldwide today. The tragic Apollo 1 fire in 1967 forced NASA to completely overhaul its safety protocols and material science, leading to advancements that benefited industries far beyond space. NASA invested heavily in developing fire-resistant materials, rigorous testing methodologies, and improved environmental controls for spacecraft. Here's what most people don't know. Many of these innovations, from flame-retardant fabrics now used in commercial aviation and public buildings to advanced smoke detection systems, directly influenced modern fire safety standards globally. This tragic event spurred safety research that still protects countless lives in everyday settings. While most people associate Tang with astronauts, the moon landing era pushed much more sophisticated advancements in food preservation. Astronauts required lightweight, nutrient-dense, and easily storable food that could withstand long missions. NASA perfected and scaled processes like freeze-drying and retort packaging, making it possible to store food safely for extended periods without refrigeration. These innovations significantly improved the safety and longevity of packaged foods. Today, these advancements contribute to the convenience of camping meals, emergency rations, and even the shelf-stable baby food found in supermarkets, making nutritious food more accessible and durable globally. Memory foam, renowned for its pressure-relieving properties, was originally developed by NASA's Ames Research Center in 1966. Its initial purpose was to improve crash protection for airline pilots and to cushion astronauts during the intense G-forces of launch and re-entry for Apollo missions. The material, officially known as temper foam, was designed to evenly distribute body weight and absorb impact, making it ideal for high-stress applications. While it took some years for commercial adoption due to high production costs, this ingenious space-age material eventually revolutionized mattresses, pillows, and even prosthetics, offering unparalleled comfort and support to millions worldwide. The images of Earth from space, particularly the Earthrise photo from Apollo 8 in 1968 and the blue marble image from Apollo 17 in 1972, profoundly altered human consciousness. Seeing our planet as a fragile, finite blue sphere floating in the vast blackness of space sparked a global realization of environmental vulnerability. Most people don't realize these iconic photographs were instrumental in galvanizing the nascent environmental movement. They provided a powerful visual metaphor for our shared home, directly contributing to the momentum that led to the first Earth Day in 1970 and significant global conservation efforts. The Apollo program generated an unprecedented boom in STEM, science, technology, engineering, and mathematics education, inspiring an entire generation. The urgency of the space race and the grandeur of the moon landing led to significant government investment in educational programs and scientific research. Most people don't realize that the sheer demand for engineers and scientists to work on projects like Apollo led to the rapid expansion of university departments and the establishment of new research centers across the U.S. This created a lasting pipeline of innovators who would drive technological progress for decades, shaping our world in countless unforeseen ways. The advanced materials developed for Apollo spacecraft were revolutionary, impacting industries far beyond space. The need for materials that were incredibly strong, lightweight, and capable of withstanding extreme temperatures and pressures spurred innovation in composite materials like carbon fiber and advanced epoxy resins. Here's what most people don't know. These materials, initially critical for the structural integrity of rockets and command modules, are now ubiquitous in modern aerospace, high-performance sports equipment, and even structural components in construction. Their development for space exploration fundamentally changed how we design and manufacture durable goods. The exacting standards of cleanliness and quality control demanded by the Apollo program set new benchmarks for high-tech manufacturing. To prevent contamination of spacecraft components and ensure absolute reliability, NASA established incredibly stringent clean room protocols and rigorous testing procedures for every single part. Most people don't realize that these hyper-precise methodologies, honed to perfection during the moon missions, became the industry gold standard. They fundamentally influenced manufacturing practices in critical sectors like semiconductor fabrication, pharmaceuticals, and medical device production, ensuring product safety and operational excellence globally. Transmitting clear voice and data signals from the moon over hundreds of thousands of miles required pioneering digital signal processing techniques. This necessitated the development of advanced algorithms for data compression, error correction, and noise reduction to overcome the immense challenges of deep space communication. Here's what most people don't know. These foundational techniques, born out of necessity for the Apollo missions, are now silently embedded in almost every digital device. They power your smartphone's audio, enable high-quality video streaming, and ensure reliable data transfer across the internet, quietly underpinning our connected world. The Apollo program's success required an entirely new approach to ground support and global communication networks. To track spacecraft across vast distances and maintain constant communication, NASA built a worldwide network of tracking stations. This infrastructure, including massive parabolic antennas and advanced telemetry systems, demonstrated the immense potential of global communication. Most people don't realize that this foundational global network, developed to connect Earth to the moon, directly foreshadowed and influenced the development of modern satellite communication systems and the Internet's early distributed architecture, enabling instant global connectivity today. The Apollo program's drive for miniaturization in electronics had a direct and profound impact on our daily lives. The Apollo guidance computer's remarkable feat of packing computational power into a compact space necessitated the development of smaller transistors, more efficient circuit board layouts, and innovative packaging techniques. Here's what most people don't know. This relentless pursuit of creating smaller, lighter, and more powerful electronics for space missions directly set the trajectory for the tiny, yet incredibly powerful devices we carry in our pockets today, like smartphones and smartwatches, fundamentally transforming personal technology and making it ubiquitous. The lunar rocks and soil brought back by the Apollo missions, totaling 382 kilograms or 842 pounds, fundamentally revolutionized our understanding of the moon and the early solar system. These precious samples provided invaluable data, allowing scientists to pinpoint the moon's age, understand its geological evolution, and even shed light on the formation of Earth. Here's what most people don't know. The analytical techniques developed to study these extraterrestrial materials also advanced terrestrial geology and material science, inspiring a new era of planetary exploration and revealing secrets about our cosmic origins far beyond our closest celestial neighbor. While often seen as a Cold War victory, the moon landing inadvertently laid the groundwork for future international space cooperation. The immense scale, complexity, and cost of sustained space exploration post-Apollo led to a growing realization that global collaboration would be essential. Here's what most people don't know. The competitive US-USSR space race gradually shifted towards dialogue and joint ventures, culminating in the Apollo-Soyuz test project in 1975. This symbolic handshake in space demonstrated peaceful cooperation, directly paving the way for larger international projects like the International Space Station, proving that even fierce competition can lead to unity. The moon landing program also spurred significant advancements in modern weather forecasting. While weather satellites existed before Apollo, the program's massive investment in rocketry, orbital mechanics, and ground tracking infrastructure significantly enhanced their capabilities and reliability. The detailed imaging and data transmission networks developed for lunar missions were directly applicable to meteorological satellites, leading to vastly improved weather prediction models and climate monitoring. Most people don't realize that the reliability with which we can forecast hurricanes, track global climate patterns, and issue timely warnings today owes a substantial debt to the technological thrust of Apollo. Fuel cell technology, a key component for clean energy today, received a major boost from the Apollo program. The Apollo command and service modules relied on hydrogen-oxygen fuel cells to generate both electrical power and potable water for the astronauts, a critical necessity for mission longevity. This compact, highly efficient, and environmentally friendly power source represented cutting-edge technology for its time. Here's what most people don't know. This advanced fuel cell research, driven by the unique demands of human spaceflight, continues to inform modern clean energy initiatives, particularly in hydrogen fuel cell vehicles and stationary power systems, providing a cleaner alternative to fossil fuels. Finally, the Apollo program served as an immense economic stimulus and job creator, fundamentally reshaping regional economies. At its peak, Apollo employed over 400,000 Americans, engaging thousands of companies and universities across the nation. With a total cost of $25.4 billion, over $200 billion in today's dollars, this colossal federal investment injected massive capital into key sectors like aerospace, electronics, and engineering. Most people don't realize that this effort didn't just put humans on the moon. It created entirely new industries, developed a highly skilled workforce, and catalyzed economic growth in states like Florida and Texas, whose legacies continue to drive innovation today.